right, everyone. In the last module, which was Monday, I talked about kind of if statements. We also talked about event handlers or events, what are events, and what are event handlers. Okay. And last week we talked about like not just like literally how to code, like the literal syntax, but like kind of concepts of like how to code. Okay. So I'm just going to kind of go over that real quick, which is, when you part the biggest aspect or one of the biggest aspects of coding is not like literally memorizing, the coding syntax or whatever. I mean, you can find references of that online, but it's how to solve problems, okay? How to look at a problem and go, how are we going to solve this problem, right? And, we talked about different things to think about, like make sure you're defining what the problem is. So for instance, in the popcorn lab, what's the problem? Well, the problem is you're trying to make a shape appear randomly at a random part of the canvas over and over. How do we do that, right? That's what I'm essentially asking for. Whether you use the random function or whatever else doesn't really matter. The point is, what is the problem and are we addressing the problem? We talked about breaking the problem into smaller parts. Okay. Now, in this class, we're not really tackling super complex problems, but if I was programming a video game where, my character runs around and the character fights goblins and whatever and scores points and collects things, it's like, well, that's a lot of different things, right? Character has to move. That's one problem. Character has to fight someone somehow. That's another problem. How do we do that? Character needs to be, there needs to be some sort of user experience that shows the score system. How do we know when the game is over? Do you score 100 points? Is the game over? Is it timed? Whatever. So each one of those is like a smaller problem of a much bigger problem, which is we're making a video game, right? Or whatever. I'm using a video game because that's more fun. But it's like, you're building an application to log in to a bank system or, turn on your lights with a smart, you have smart lights and using an app or something like that. Sometimes it's easier to solve a simpler problem than the one you've been given. So if I'm given the problem of my character, let's go use my video game analogy, my character needs to collect 10 coins. Okay. That's great and everything. But first, let's just get the character to be able to collect one coin. And then we'll worry about whether they can get 10 or not. You know what I mean? So it's like you got to start smaller. And then once you sort of got that going, then you can kind of work your way up to a more complicated one. Different perspectives. This means thinking about things differently, talking to people differently. We talked about the concept of pseudocode, where you're not even writing actual code. You're just kind of stating what you need to do. So it's like, I need to place a circle at a random position. It's like, okay, well, the first thing is I need a variable that holds that random position because that has to be somewhere in your code. I have to set that variable to a random position somehow. And then I need to, that circle needs to use that random position somehow, right? And so this might be like my pseudocode. Now, this is not going to work if I were to put this into P5, but it doesn't, it's just pseudocode, okay? When we start getting more complicated, the next concept we're going to talk about is what's called a flowchart. Okay. Now, flowcharts are when you sort of figure out the ins and the outs of what is actually going to happen in your program. So, um, charts and maps are usually used to simplify data and information. For instance, a Google map is a simplification. Let me say that again, this time correctly. A Google map is a simplification of an actual terrain. In other words, what I mean by that is like, this is what the actual, satellite data looks like. It's probably even more complicated than that. But this is like, really, do we need to see every nook and cranny and every tree? This is much easier. Even though this is not the same as this, they present the same data. which is like, I am trying to get from point A to point B, right? And this is just easier for me, at least, to look at than this, okay? So the point of a flowchart is to kind of simplify the data and the decisions being made in a program, okay? This is originally came up with by an engineer whose name is Frank Gilbert. This came up, he was an engineer, believe it or not, and he called it a process chart, and this got introduced to the American Society of Mechanical Engineers in 1921. Okay. Oops. So when we make a flow chart, there's certain symbols that we use to kind of denote things. First is like, well, okay, where do we start as a program and where do we end, right? So it's like, if I'm launching, I don't know, insert name of social media app here, like TikTok or something, it's like, well, the first thing is I literally click on the app and that starts everything, right? TikTok doesn't just run on its own. I have to engage with it on my phone or my tablet or something like that, right? So that's the start. And then it pretty much runs until I basically tell it to exit, right? So, if you hit exit or some other command within the program, that will get you out of that app, right? Or if you're working in Adobe Photoshop, Photoshop runs until you officially go to file quit, right? Or use some sort of keyboard shortcut that would quit the program, right? So there's a way to start and there's a way to end, okay? If we have an action, like, I'm just making up things here, but it's like, okay, in my program, two numbers get added to each other. That's an action, adding one number to another number. Or choosing a brush in Photoshop. Or, I don't know, counting down from 100, 100, 99, blah, 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 blah. Okay. These are all actions, okay? It might sound, one thing you might notice is that when I talk about actions, it's a lot like when I talked about functions. Remember, functions could really be anything, right? A function can add two numbers to each other. A function can, paint, make us, fill color blue or whatever it is that we wanted to do. And that's kind of the same thing here. Actions a lot of times are eventually, not always, so I don't want to give any absolutes here, but usually if your program is doing an action, there's probably a function related to it if it is, programming based. Sometimes your program's going to need to make decisions. Okay. If this happens, then this happens. If this, then that happens. Notice how I keep saying the word if. So a lot of times, not always, I don't want to give any absolutes here, but a lot of times if you're deciding something in your program, you're probably going to need an if statement somewhere in your code to be able to facilitate that. Okay, so I don't know. If the player loses all 5 lives, then the game is over. Okay. If the player collects 100 coins, then they get an extra life, right? So the decision is, do they have 100 coins or not? If they do, extra life. If they don't, keep going or whatever happens in the program, okay? And then if your program is going to let your users do something, you need to have an input, okay? Input means like the user is going to click a button or click a mouse or, shake their phone or whatever it is you want them to do. Okay, you figure out what action you want, but that information has to be given, inserted in the program somewhere. Okay, and so by the way, we use diamonds to show, a decision, and we use this kind of parallelogram here to show input. It's also output. What is output? Well, output is any time that my program asks me something or tells me something. So for instance, let's say here on this is a Mac OS X operating system here. If I were to try to delete this, it's giving me this information. Do you want to delete these items? Okay, so that's output. It's telling me something. It didn't have to technically do that, but it's usually useful to give users information so that they can make decisions or they know what's happening in the program. The easiest way to think about this is like a video game. Okay. If you're a video game, you have characters with like a number of lives or percentages of life. It goes from 0 to 100. It's like, how do I know if my character is dying? Well, if I know how much health I have and I know I only have 10% of 100% health, then my character is not doing very well, right? I need that information because otherwise I don't know, right? You know what I mean? So you have to give output to users. Now, output doesn't always have to necessarily be text. It could be audio, like in a video game, if your character starts like grunting, like, then it means like, okay, your character's probably dying. Or maybe it's visual, your character looks sad or beaten up or something like that. But you need to give the users information so that they can make decisions. Otherwise, how would they know? You know what I mean? So if how would I know whether or not this is going through unless the output here is one, it's literal text of me, telling me I'm going to empty it. And two, I can actually see the pieces disappear. Okay. All right. So I'm going to give you guys a scenario here. And I'm going to use Figma. We'll talk about Figma actually in another video today. Figma is a program that is very useful for quick prototyping. And we're going to just use it to make these shapes and such real quick. All right. All right. Imagine a scenario where we want to create a program that chooses a random number between 1 and 10. After choosing the number, it decides or it figures out if the number is even or odd. If it is odd, it will print out the word odd to the console. If it's even, it will print out even to the console. Okay. So don't worry about what I'm doing. We'll talk more about how to like use this program to draw. It's very basic. If you have any experience with Illustrator, I'm sure you can pick up Figma very quickly. And we'll talk more about it later. So my program has to start. Okay, here's my start. And in this case, the program just starts. I don't think we even need anything to happen before the program starts. Like we don't need any specific information or anything. I'm just going to make this bold. All right. And the first thing that happens, or the first thing I'm going to need to do is we need to have an action. What is the action? The action is choosing the random number between 1 and 10, right? I need some way for the program to do that. So I'm just going to say, okay, let's just use a rectangle here. Once again, don't worry about what I'm doing here. We'll talk more about how to use Figma specifically later. Choose a number between 1 to 10. Okay. I'm just going to connect these with lines or arrows. There you go. Actually, I kind of don't want these bold. Let's make this medium. All right. All right. So we got our action. Our action is it's choosing a random number, whatever that number is. 1, 10, 0. I guess it's between ones. It's not 0, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it has to figure out, is the number that's chosen, is it even or odd? That's a decision point. Okay. So I'm just going to draw a little diamond here. Is the number chosen even or odd? Okay. Chosen. I will tell you that English, grammar is not my strong suit by any stretch. I'll be the first to tell you that. And so will my mom. All right. She had to correct my papers in high school. All right. Is the number even or odd? That's a decision. Okay. Is it even? Is it odd? Okay, now in reality, the way we would do that with P5 is writing an if statement. Okay, I can already think about how we do that, but we're not worried about writing any code right now. We're just plotting how the program is going to work. Okay. All right, next, let's just say that it chooses odd, what happens? Well, we want it to tell the user through the console. That would be output, which is this kind of parallelogram. So I'm just going to say, all right, I'm just going to draw a parallelogram using the pen tool. I'm hoping you guys, since you guys have taken 300, have at least basic idea of what how to create using the pencil. I'm just going to make this gray. Oops, let's make this like a lighter gray. All right. All right. This is if it's even, I wanted to print the word even to the console. Okay. This is a me thing, but when I do flowcharts and there's a decision, I like to write what the decision is on the arrow so that it's kind of more clear to people. So for instance, what I mean by that is I would like literally write the word like even right there. Now I'm using Figma. You could also draw this, and if you're working with other people, you're probably going to draw it, or at least, if it's informal, but, so that's if it's even, and if it's odd, it's pretty much the same thing, just use the word, print the word odd instead of even. Okay. Excuse me. And I'm just gonna, once again, don't worry about how I'm doing this just yet. I will have a video later where we go over Figma. You could do all this in Illustrator or Photoshop, by the way. I'm just using Figma because it's a little faster. And that's kind of it. I mean, if you read the problem, it doesn't say to repeat. Like, in other words, it doesn't say like, okay, after you choose a number, go back and choose another number. The program just kind of ends, right? So what I could basically do is say, okay, well, starting and ending is a circle. And then that's it. And let's say end. Okay. And that's kind of my flow chart. Program starts, chooses number, decides if it's even or odd. If it's even, prints to console, program done. If it's odd, prints odd to console, program done. Now let's just say for the sake of argument that if, let's say in my statement, it was say, okay, well, if it prints odd, I want you to keep repeating it until till you get even. I don't know why you want that, but let's just hypothetically say that's it. Then after this would actually go back to this point, right? Because if you're repeating it, it's like, well, what part do we start repeating? Well, it's the random number part, right? So then it's like, okay, this is a little bit kind of like, remember we did story, I talked about story maps and such. This is kind of the same idea. It's not the greatest, but so hopefully you kind of get the idea here that it's like, okay, you repeat and you go back. If it chooses odd, if it's even, then the program's done. Okay. And if I go back and you look at my example, this is pretty much what I just did, just a little easier. I kind of did it separately. It doesn't really matter. They both go to the same ending. So I probably should be this. Code-wise, you'd probably just make it go to the same thing. So that's a little bit easier. All right. That was a pretty simple problem, or relatively simple, but let's do something a little more complex. Okay. Let's say, in this case, what we're doing is I am making the flow chart for an ATM machine. I'm assuming everyone knows what an ATM machine is. You go to your bank, you put your card in, you decide, you make decisions on taking money out, putting money in, that kind of stuff, right? Now, this is a more complicated flow chart. And also, because there's so much input and output, I actually color coded it. So like in this case, peach is when the computer is asking for information or giving, sorry, I take that back. Peach is when the program is giving the user information. Green is when the user is giving the program information. Okay, so it's input output. Okay. So what happens? Well, you start off at an ATM machine, right? And it's like, you hit it and it starts, right? The next thing is usually most ATM machines will ask you to put in your card and put in a PIN number, right? This is to verify that, you are a bank member and you have an account with them, right? So it's, to get the user to understand that, it helps to tell them, right? Like, please put in your card, please type in PIN number, because otherwise people may not know to do that. So that's why here I have a little bit of a output from the computer or the program saying, type in your PIN number, right? Then the user has to do something. The program doesn't continue unless the user types in some number. It doesn't technically have to be right, but it has to be some sort of input, right? So the user is going to have to type in a number, okay? Then the first question really is, does the user, or, is the password that the person put in, is that the correct PIN number? And, that requires a lot of programming. We're not talking about that right now. But essentially what's happening is it's going to go check, the save password to see if you put in or save PIN number. And it's going to see if it's the correct PIN number, right? So in this case, I didn't write it down, but let's just say that it is wrong. Well, we need to go back to here, right? Because we need to give them another chance. Or at least most programs probably would. Otherwise, you're going to get users who are not happy because every time they do something wrong, the entire program shuts down, right? Another thing you might want to do is tell them that they made a mistake. If people don't know they made a mistake, then they're unlikely going to change what they're doing, right? So if the user doesn't know that they typed in the wrong PIN number, then they may just put in the same PIN number again, right? And that doesn't work, or it's not helpful in my opinion. So it's probably good to tell them that before going back to an earlier part of your program. All right, let's say they did put in the correct PIN number. The next step we really want to have them do is like, what do they want to do, right? Now, there are different things you can do with an ATM machine. You can check your balance. You can withdraw money, which means to, take out X amount of dollars. You can also deposit money, right? You have some cash or you want to deposit a check, you could do that too. So this is a decision. So the decision is, what does the user want to do? Okay, so you have, in this case, there's the decision point, which is something we're going to have to check for in our code. Let's just say for the sake of argument, they want to see their balance, okay, which is how much money you currently have in your account. So they say, I go down the balance route, I display the balance. The user doesn't really have to do anything. There's nothing that the program needs in order for the user to, see their balance. We already put in the PIN number here. So then you show the balance, and then that's kind of it, right? Now, we could end the program right there, but let's just say for the sake of argument, we don't want to necessarily, we want users to be able to do multiple actions, meaning they could check their balance and then they could go back and maybe deposit money or, withdraw money or something like that. So why don't we ask them another question? Do you want to do another action? Yes or no. Now, if it's no, then that's it. The program is now done. We've completed our whole segment here. If it's yes, then okay, let's go back to this point, right? We don't need to go back here. I mean, you could. I don't really think that's necessary unless you're very, worried about security or something like that. So we're not going to go all the way back here, but we're going to go back here where the user can make decisions. Let's just say for the sake of argument, the next thing they want to do is a withdrawal. Okay, how much money do they want to withdraw? We don't know, right? I mean, I suppose you could have a program that always gives you the same amount of money, but most people want choice, right? You want 20, 40, 60, 80, 100, something like that, right? So maybe just for the, I'm going to ask them, in this case, I want to ask them, how much money do you want to take out? That is an output of the program, because otherwise, how would the user know that we need a number? The user is then going to give us that information. They're going to type out or hit a button that says like $50 or $100, and then it's going to do an action. The action is to dispense money. Okay. Now, technically, what I really should have done is there should have actually been another decision point. The decision point really should be, does the user have enough money to cover how much they want to take out? In other words, like if they ask for $100, but they only have $50, then obviously that's not going to work unless you're going to do credit or something like that. So that would actually be another sort of decision point, but let's keep it a little simple. I should have done that, but oh well. They get their money. Now what? Do they want to, and is that it? Or do they want to do something else? Well, that's another question. No, they don't want to do anything else. Program done. Yes. Let's go back. And it goes back here. Let's say we are going to allow them to deposit money. Okay. Now, how much, let's just say for the sake of argument, now I know a lot of ATMs have like a sort of mechanism that can count. If you give it cash, it'll like count how much cash you give it, or it can tell how much the check is. But let's just hypothetically say we don't have that technology. So I'm going to literally ask the user, how much money are you depositing? Okay. And for now, we're just going to use the honor system that if they tell me $100, it's $100. Okay. So that's, once again, I'm asking, this is output from the program saying, hey, how much do you want to deposit? You type in that number, the user has to do something, then it, I know it says deposit, deposit. Yeah, it'll deposit the money. That's the action where it takes the money in. And then once again, are we done? Well, that's a question, right? It's a decision. If we're done, or we say no, we don't want to do another action? No. If we do want to do another action, yes. And then we can go back and look at our balance again, or our withdrawal or something like that. And this is a more complicated flow chart, okay, as opposed to the first one. Now, the one thing I want you guys to really kind of understand is notice that in both of these, there is no like code. There's no like, it doesn't matter if this is JavaScript or, some other programming language. Nothing that we did had anything to specifically do with JavaScript, right? It's all problem solving. It's all like, this happens, then this happens, then this happens, and then we decide something. And then if it's this, it's this, and if it's this, it's that, right? So my point here is that the point of a flowchart is to think about your problem, but not in a specifically code syntax kind of way. Like, yes, we need a way to choose a number between 1 to 10, but different languages like JavaScript or C# or whatever may have different ways of doing that. Or, how do we know if the number is even or odd? There's different techniques to figuring that out. That's not the question, is how do you write code that figures out if it's even or odd? The question is the number even or odd, period? And then if it is or it isn't, something happens, right? And that's kind of the point of a flowchart, is to really think about, what you want to do without having to worry about literal syntax. That'll come later. Like once you get the flowchart going, then it's like, okay, how do I choose a random? How do I figure out if it's, even or odd? How do I figure out if there's 3 choices, which choice the user wanted, right? How do I know if they want to do balance, withdrawal, deposit? Maybe you set it up to keys on your keyboard. You know, if you hit the 1 key, it's balance, it's 2 key, it's withdraw, it's 3 key. Maybe use point, maybe it's based on your mouse. Maybe you click 5 times, that's deposit, and 10 times it's withdraw or something. I don't know. There's a lot of ways you could do it. The point is not how you do it. The point is like just the fact that we're trying to get that done. Okay.